All right, let's get into something that sounds like it's straight out of a sci-fi novel, but is actually a really serious scientific thought experiment. I mean, just think about that for a second. What if we weren't the first ones to do this whole civilization thing? What if way, way back, long before us, another species built cities, harnessed energy, dominated the planet, and then just vanished? How would we even know they were here? So, this wild question is at the very heart of what's called the Silurian Hypothesis. And yeah, for any Doctor Who fans out there, you're right. It is totally named after that intelligent reptilian race from the show. But this isn't about fiction. It's really about using a crazy idea to ask some pretty deep questions about geologic time and, well, our own legacy. Okay, to really wrap your head around the timescale we're talking about, the original paper offers this perfect analogy. Picture it. It's 70 million years in the future. A couple of intelligent raccoons are huddled around a fire, and in the distance is this eroded, lumpy mountain that kind of looks like it used to have faces on it. Could they possibly comprehend what we were? Now just flip that. What if we're the raccoons, looking back? Right, so this is the key thing to remember. The Silurian hypothesis is not a theory that says ancient lizard people were real. It's a formal question, a thought experiment, put together by an astrophysicist, Adam Frank, and a climatologist, Gavin Schmidt. They're basically asking, hey, if some civilization existed millions of years ago, what would the evidence look like in the rock layers? And could we tell it apart from just nature? So the first thing everyone asks is, okay, but where are the buildings? Where are the fossilized iPhones? And look, after millions upon millions of years, the simple, brutal answer is they'd be gone. Completely. Finding direct proof would be like trying to find one specific needle in a haystack the size of a planet, a haystack that's been run through a blender and buried for eons. And get this, our sprawling cities, everything we've built, it covers less than 1% of the Earth's entire surface. Now combine that tiny fraction with the fact that becoming a fossil is an incredibly rare event to begin with, then add on top of that the fact that so little of the Earth's ancient surface is even exposed for us to look at today, the chances of us just stumbling upon the fossilized ruins of, say, a pre-human Chicago, they're just vanishingly small. And this right here, this really nails down the problem of time. Dinosaurs were around for over 150 million years. That's a huge window of opportunity to leave fossils all over the place. Us? Our industrial age, the part where we've really been changing the planet's chemistry, it's been maybe 300 years. Geologically speaking, that's not even the blink of an eye. It's nothing. A civilization that rose and fell over, say, 100,000 years could so easily just disappear from the fossil record. So if we can't look for a fossilized skyscraper, we have to look for something way more subtle. We have to look for indirect evidence. We're talking about the huge planetary scale changes that an industrial society would leave behind, baked right into the rock layers themselves. It's what scientists call a geological fingerprint. And these are the kinds of clues we're leaving behind right now. You'd see a sudden, massive spike in certain carbon isotopes because of all the fossil fuels we've burned. You'd find layers of weird synthetic pollutants like microplastics and industrial chemicals that nature just doesn't make. You might even find rare radioactive elements with super long half-lives like plutonium-244, which points to nuclear reactions. It's not any one of these things, it's the combination of all of them happening at the exact same time in the rock that just screams industry. Now this is the potential smoking gun. We're comparing our modern carbon spike to a huge natural warming event from 56 million years ago. Back then, a ton of carbon got released, sure, but it happened slowly, over tens of thousands of years. Now look at our era, the Anthropocene. It's not a gentle slope, it's a vertical wall. The sheer speed of the change is what could really set an industrial civilization apart from a natural event. Okay, so we've figured out what to look for, right? We're looking for this sudden, multi-layered chemical signature in the rock. But here is the big twist in this whole story. The point of all this research was never actually about finding an ancient civilization of smart dinosaurs. This quote from Adam Frank, one of the authors, says it all. The very scientists who came up with the Silurian hypothesis, they don't actually think it happened. They've looked at the geologic record and they see no evidence for it. So, naturally, you have to ask, what's the point then? Why go to all the trouble of writing a paper about a hypothesis that you yourself don't even believe in? And the answer is actually brilliant, and there are two parts. First, it's a way for us to understand ourselves. By defining what a civilization's footprint looks like, we get a much clearer picture of the incredible, long-lasting impact we're having right now in our own era, the Anthropocene. And second, it's a roadmap for finding life elsewhere. When we finally start drilling deep into the rocks on Mars or Venus, this thought experiment tells us exactly what kind of chemical clues or technosignatures we should be looking for. You know, this whole exercise of looking for ghost civilization in the past is really about holding a mirror up to our own civilization in the present. It forces us to think about our future and what kind of legacy we're choosing to leave behind. And this leads to a really fascinating final thought, something called the sustainability paradox. Think about it. All the things that leave the biggest, ugliest geological scar, burning fossil fuels, creating pollution that never goes away, those things are, by definition, not sustainable. So a truly advanced civilization that manages to stick around for millions of years would have to become incredibly clean and efficient. It would recycle everything, and in doing that, it would leave a much, much smaller footprint, maybe one that's totally invisible. The very thing that would let them survive would also erase them from history. And that's really what this is all about. The Silurian Hypothesis isn't about some lost world. It's about us, right here, right now. Are we okay with leaving behind a brief, dramatic scar in the rock, a layer of plastic and weird isotopes that screams bright but short-lived? Or can we figure out how to build something that lasts, even if it means our ultimate legacy in the rock is a little bit quieter? It really asks us to decide, what kind of ancestors do we want to be?